Good morning, guys. In the last class, we discussed what is the DevOps and why DevOps. So DevOps is the combination of development plus operations. So DevOps is called as a culture that companies are following to automate application build and deployment process. And we can call DevOps is a process which is used to automate build and deployment process of our application. DevOps nothing but set of practices we are following to speed up application delivery process. So the main aim of the DevOps to establish collaboration between development team and the operations team. So here by using these DevOps practices, we can deliver the application to client quickly with a high quality. So as a DevOps engineer, we are responsible to automate application build and deployment process using DevOps tool chain. Okay. Now here, what are the responsibilities of development team in the project? So for every project, a development team will be available. So roles of development team. So what development team is going to do in the project? Development team is going to understand the requirements given by the client. Clients will give the requirement according to their business. Developers will understand the given requirements and they are going to analyze the requirements. What are the requirements given by the client? Is it possible to do those requirements implementation or not? Or are there any challenges with the requirements? Are there any showstoppers in the requirements that will be analyzed by the development team? Once it is completed, then they will prepare designing for the project. So what is the architecture we need to follow? Do we need to develop it by using monolith architecture? Or do we need to develop that by using microservices architecture like that? Developers are going to design the project and they are going to come up with development. They are going to come up with development, right? Understanding the requirements, analyzing the requirements, designing the requirements, development of the requirements, and the next one, they will perform unit testing. So whatever the development that developers are doing, is that code working as expected or not? Developers only will test it. That concept is called as unit testing. Once unit testing is completed, if they feel everything is working, then they will go for code integration. Here, source code repository server will be available. Source code repository server will be available, right? Understanding the requirements, analyzing the requirements, designing the requirements, development of that, unit testing, and code integration. These activities will done by development team in the project. Okay. Similarly, we will have QA team. So nothing but quality assurance team will be available in the project. These people prepare prepare test scenarios, prepare test scenarios, prepare test cases, prepare test cases, execute the test cases on the project, execute test cases on the project. That means, so what requirements are given by the client, what functionality we need to test in the project. So they will prepare a document with all the scenarios that they have to test. And scenario nothing but high level. And based on the test cases, they based on the test scenarios, they are going to prepare test cases and execute test cases on the project, report to bugs, report bugs, right? So if any functionality is not working as expected, then this is a testing team. QA team is also nothing but software testing team. So these people will prepare the test scenarios and they will prepare the test cases. They will execute the test cases on the project and they will report bugs in the project and certify quality, provide QA certificate, provide QA certificate, QA approval. We can say that if every functionality is working as expected by the client, then these people are going to provide QA approval. Development team will be available in the project and a testing team will be available in the project. What are the roles of the development team? Development team is responsible to understand the requirements given by the client, and they are responsible to analyze the requirements. They are responsible to design the project. And development is also called as a coding part. Actual coding will happen here, and the unit testing will be available. Developers only will test whatever the code they have written. Is that code working as expected or not? So every developer will perform unit testing on their code. Once their unit testing part is completed, developers will perform the code integration. All the developers code will be integrated at one place. So we are going to use GitHub or Bitbucket for that code integration part. So once the developer's code integration is completed, then testers has to test the application. What are the roles of the testing team in the project? So for every project, a testing team will be available. That a testing team is responsible to prepare test scenarios, prepare test cases, execute test cases on the project, report the bugs if anything is not working. If any functionality is not working expected by the client, these testers will identify the bugs and they will report the bugs. When the bugs are reported by the testers, then developers are going to fix that bugs. Right. So once all the bugs are fixed, once everything is working in the project, then here they will provide the QA approval. That means this project is certified for the delivery. Like this, they are going to provide the QA approval. Now, here our operations team will be available. Roles of operations team. Roles of operations team. So as a DevOps engineer, we are called as operational team member. What are the roles of operational team in the project? So the first important thing for the operational engineer is set up infrastructure. Set up infrastructure. That means how many machines are required to run our application, what database is required for our application, what network is required for our application, load balancers required for our application, all the infrastructure that is required for the application, we need to set up the infrastructure. Now, some companies will go for on-premises infrastructure, some companies are going for cloud infrastructure. So like AWS, Azure, GCP, cloud platforms are available. So by using the cloud platform, we need to set up infrastructure which is required for the project. Infrastructure, nothing but machines, computers that are required, servers that are required, and next one is databases that are required, security that is required, storage that is required, network that is required for our project, backups that are required for our project. Okay, user accesses, all that stuff. So here for the project, whatever the infrastructure is required, that as a DevOps engineer, we need to set up the infrastructure. So here we can set up the infrastructure in the on-premises or in the cloud. On-premises means on-premises means so we are going to purchase all the computers and we are going to set up that infrastructure. Cloud means AWS cloud infrastructure we are going to set up. So which tool is available to set up infrastructure, guys? In the last session, we discussed which software is available to set up infrastructure in the cloud platform. Can you please respond to my questions? Which software is available to set up infrastructure in the cloud? AWS is a cloud. So how we will set up infrastructure in the AWS cloud? Docker, Terraform, Ansible, Jenkins, which one? Terraform. Terraform is a software which is used to set up infrastructure in the AWS cloud. Okay, so we will use Terraform. We will use to set up infrastructure. Terraform is the tool which is used to set up infrastructure in the cloud platform. Instead of setting up the infrastructure manually as a DevOps engineer, we are going to use a Terraform tool, Terraform software we will use to set up infrastructure in cloud. So which cloud supported by Terraform? Is it only for AWS or it is common for all the cloud platforms? Terraform software is used for only AWS or it is common for all the cloud platforms? It is common for all the cloud platforms. Terraform can be used to set up infrastructure in the AWS cloud or Azure cloud or GCP cloud also. then fine. Once infrastructure setup is completed, we need to set up some softwares in the machines. If you just to take a machine, our project will not run. So we need to install some softwares which are required for our application execution. That is called configuration management. As a DevOps engineer, we are responsible for configuration management in our infrastructure. Configuration management means installing the softwares, OS updates, all that stuff we are going to perform by using configuration management. So is it easy to manage the configurations manually? Manual configuration management is recommended. Automated configuration management is recommended. Come on, guys. Automated configuration management is recommended. Why? Because I have 100 machines. In 100 machines, I want to update my operating system. Going to 100 machines, updating operating system one by one is a time taking process. So that's why we are going to automate configuration management in the project. So what is the purpose of that configuration management? To auto what are the softwares that are required for our application? Those are softwares we are going to install in our machines. Which tool we are going to use to automate configuration management? Which software is available to automate configuration management in the project? Ansible software is available. Ansible software we will use to automate configuration management. Okay, guys. Nobody is interested to do in the manual process because it is time taking process and it is error prone. If you do the configurations manually, there is a chance of doing the mistakes and it will take a lot of time. To automate configurations required for the project, we will go for Ansible. Creating infrastructure manually is a time taking process and there is a chance of doing the mistakes. And for every project, we need to set up the infrastructure. For that, we are going to use Terraform. By using Terraform, we can set up infrastructure in the cloud, right? By using Ansible, we can automate configuration management. And we are responsible for, as a DevOps engineer, we are responsible for source code repository creations, source code repository creations, source code repository management. Now, what is source code repository, guys? Multiple developers will be available in the project. All the developers code should be integrated at one place. Developers will be working from different locations and will be working from different places. So they are working on the same project. They are working on the same project, so that the code should be integrated at one place. So to integrate the developers code at one place, we are going to use source code repository. Who will create the repository for the developers? Who will manage those repositories? That is the DevOps engineer responsibility. Source code repository management should be taken care by DevOps engineer. So which is software is available to manage our source code? Which is software we can use as a repository servers, guys? So we are having GitHub, or earlier people used it to work with the SVN, GitHub, Bitbucket. We can use for source code manage integration, for source code management, for source code integrations. All right. So developers will write the code. Developers code should be stored at one place. For that, we are going to use source code repository like SVN, GitHub, Bitbucket. We can use for source code integration purpose. So it is the responsibility of the operational engineer to set up that source code repository for the developers so that developers will integrate the source code at one place. Then once the source code is given by the developers, then as a DevOps engineer, we are responsible to build the source code, build the source code, build the source code. So now what is the build process, guys? Yesterday, so many people asked me, sir, what is the meaning of build? What is the meaning of build? Build the source code. Build the source code is nothing but compile the source, take the latest source code, take latest source code, take the latest source code here, build process, build the source code, take the latest source code from the repository, from repository. Either it is a GitHub repository or Bitbucket repository. Some projects are using GitHub repositories, some projects are using Bitbucket repository. So as a operational engineer, we are responsible to build the source code. Take the latest source code from the repository. Take the latest source code from the repository, compile the source code, compile the source code, then execute, execute unit test cases, execute unit test cases, then package the code. Package the code as jar file or war file. All these things are comes under build process. Take the latest source code from the repository and compile that source code and execute that test, execute the unit test cases of the project, execute unit test cases of the project and package the code as a jar or war file. Package the code as jar or war file. First of all, let's understand what is this compiling the source code. Guys, here one developer, suppose assume that one person is available. One person wants to communicate with another person. One human wants to communicate with another human. So if one human wants to communicate with another human, we are using one language as a mediator. Okay, guys, we are using one language as a mediator. If one person wants to communicate with another person, like Hindi, English, Telugu, so there are several languages available. So by using one of the language, these people are going to communicate. Hindi, English, or Telugu, or any language, whatever, both are comfortable. So if one person wants to communicate with another person, one language is required. So similarly, if one person wants to communicate with a computer, what language computers will understand? Computers will understand only binary language. So this is a computer. One person wants to communicate with the computer. Computers will understand only ones and zeros. Computers will understand only ones and zeros. Now, we cannot talk ones and zeros. We can't speak in ones and zeros. Computers cannot understand our languages. Now here, if one human wants to communicate with another human, we need one language as a mediator. So there are several languages available which we are using to communicate: English, Hindi, Telugu, etc. Right. So these are the languages that people are using to communicate with each other. But what about one person wants to communicate with a computer? If one person wants to communicate with a computer, then also one language is required as a mediator. So that's where C language, C++ language, Java language, Python language we are using. So these are called as programming languages. English we are using to communicate from one person to another person. If one person wants to communicate with a computer, we need one programming language. So what are the programming languages available? C, C++, Java, Python. These are the programming languages we have. Here guys, now whenever we develop a program by using Java, computer cannot understand the Java directly. So whatever the Java program we are writing, that Java program we need to convert into computer understandable format. So that is called compiling the source code. Whatever the source code is developed by the developers, that source code cannot be understood by the computer. So that is a Java code they are writing. That Java code we need to convert into computer understandable format. That is called compilation. So whatever the code is given by the developers, that code will be available in the Java, that the Java code computers cannot understand. Whatever the Java code is available, that Java code should be converted into computer understandable format. That's where compilation comes into picture. It is part of the build process. So developers are writing the code. Code will be available in the repository. We need to take the latest source code from the repository and we need to compile the source code. What is the meaning of compiling the source code? Checking the errors available in the code and converting the code into computer understandable format. So once the code is compiled, then unit test cases. Developers are going to write the unit test cases. That means whatever the code that they are writing, that code is working as expected or not. For that, they will implement some unit test cases. We just need to execute the unit test cases. Who will develop the unit test cases? Developers will develop the unit test cases, and we need to execute the unit test cases of the project. So once the unit test cases are successful, we need to package the code as a jar or var. So this jar or var are called artifacts, executable format. Whatever the code is available, we are converting that code into computer understandable format, and that code we are testing by using test cases. Then we will package the code as a jar file or var file to run the application. So the code should be executed as one project, one application, gmail.com, facebook.com. Like that, we need one application with the code given by the developers. So to execute that code as one application, we need to package that code as a jar file or var file. All these steps comes under build process. Are you guys clear? Yesterday, some people asked me, sir, what is build? Now you got the clarity. Build means we need to take the latest source code from the repository. We need to compile that source code. We need to execute the test cases on that. We need to execute test cases on that. And we need to package that code as a jar file or var file. Do we need to do these steps manually? Do we have any tool to automate this build process? Yes, as a DevOps engineer, are you going to perform these operations manually? Do we have any tool to automate this process? Yes, we have some tools to automate this build process. Okay, what are the tools available to automate this build process? Maven or Gradle we can use to automate application build process. Maven or Gradle tools, Maven or Gradle we can use to automate application build process. So what is build process? Developers has given the source code. That source code is available in the repository. We need to take the latest source code from the repository and we need to compile that source code. We need to execute unit test cases of the project. We need to package that code as a jar file or var file. What are the steps we need to perform to build that code? We are going to use Maven or Gradle to automate the build process. Just by executing one command, Maven or Gradle will do all these activities. Okay, so once the code is available, perform generate code review report. Generate code review report. So what is the meaning of code review? What is the meaning of code review, guys? Coding is done by one person in the project or coding will done by set of team members? Coding is done by one person or coding is done by set of team members? Coding is done by one person or coding is done by set of team members? Coding is done by set of team members. Coding is done by set of team members. Now, how we are going to check that all the team members are following the coding standards? How we are going to check that all the team members are going to follow the coding standards? So there is a tool available to identify developers' mistakes. Generate code review report. So identify perform the code review and generate code review report. Perform code review and generate code review report. So what are the mistakes done by the developers in the code? We need to identify that. Developers mistakes we need to identify. So here, are we going to check the code line by line and check that is there any mistake? Are we going to check the code line by line and check that is there any mistake? Are we going to understand that code? No, no. So here there is a tool. There is a tool to perform this code review. Which tool is available to perform this code review? Sonar Cube. Sonar Cube is used to perform code review. Perform code review and generate report. We just need to send that report to the development team. You no need to understand the code done by the developers. You just need to take the code and review that code by using Sonar. Sonar Cube is used to perform code review. and generate code review report. SonarQube is used to perform the code review and generate review report. So you need to share that review report with the development team. So if there are any mistakes available, then they are going to fix those mistakes. They are going to fix the problems available in the code. So who is responsible to perform the code review, guys? Operational engineer is responsible to perform the code review. All right. Next one, perform the code review. Run the application, deploy the application in the server. Deploy the application in server. So what is the deployment? Keeping the application war file, or else before that, store, build artifact, build artifact into artifactory repository server. Store build artifact into artifactory repository server. So what is the meaning of storing the build artifact? So whatever the jar file or war file we are creating for the project, right? So storing the jar or war for backup. Storing jar or war file for backup. So that is called our artifact. Whenever we perform the build process, for our build process, artifact will be created. A jar file will be created or war file will be created. A jar will be created or war will be created by Maven. Who is going to create the jar or var? So the project packaging will done by Maven or Gradle. Maven or Gradle will create the jar or var file. Whatever the jar or var file is created for the project, that jar or var we need to store into Artifactory repository server. Store the build artifact into Artifactory repository server. Why we need to store the artifact into repository server? For backup purpose. Okay, guys. Whatever the war file is created for our project deployment, that war we need to store in the repository server for backup. Tomorrow, if code is modified also, we will have the backup of our previous version. Our previous version war file will be available. If there are any mistakes, if there are any problems in the latest code, we no need to worry about that because previous war file will be available, which was executing successfully. So like this project artifacts we are going to store into repository server. What are the artifactory servers available in the market, guys? What are the artifactory servers people are using in the market to store the build artifacts? What are the what are the artifact servers available? Tomcat. Tomcat is artifact. No. Nexus. Nexus, JFrog. What are the tools available? Nexus, JFrog. We can use as artifactory servers. We can use as artifact repository servers. So companies will use either Nexus or JFrog as a artifactory server. Who is responsible to store the artifact? Artifact nothing but a jar file or war file, project package, the executable format of our application. Whatever the code done by the developers, that code will be packaged into one executable format. So jar or war, that jar or war file is called as artifact of our project. Okay, so here store the build artifact into artifact repository server. Nexus or JFrog we can use as artifact repository server. Who is responsible to store these artifacts into artifactory server? Who is responsible to build the project? Who is responsible to store the build artifact to repository? Operational team. As a DevOps engineer, we are responsible for that. So which tool we are using to build that code? Maven we are using to build the code. Once the code build process completed by Maven, we will get the war file or jar file. That is the artifact. If our project is a standalone project, we will get the jar file. If the project is web application, we will get the war file. Mainly we are going with the war files. So that war file we are going to store into artifactory server. Then deploy project artifact into server. Deploy the project artifact into server. In order to run our project, we need one server. What is a server? Server is a program which will run our application. Whatever the web application we are accessing, those web applications are running inside the server. www.gmail.com, www.facebook.com. The applications which you are accessing, those applications are running in the server. Every web application should be deployed inside a server. So build plus deployment. Build plus deployment. Build means take the latest code, compile the source code, execute the test cases of the project, package the project as a jar file or war file. Once the jar or war file is created, that jar file or war file we need to keep into web server. Deploy the project artifact into web server. So what is the meaning of deployment? Keeping the war file in the server is called as a deployment. Are you getting my point? Keeping the a project var in server is called as deployment. Keeping the project var file in server is called as deployment. Deploy the project artifact into web server. Keeping the project var file in the server is called as deployment. Every web application should be deployed inside a server for execution. So whatever the code done by the developers, to execute that code, we need one server. Server is like a container which will run our application. Server is a program which is used to execute our application. So we need to build the code and we need to deploy the code. Build means compile that code, convert the code into executable format, then you will get the artifact, jar or var. Take that jar or var and keep in the server. That is called execution. So deployment. Project build plus deployment, we are responsible for that. Are you getting the clarity? What is build and what is deployment? Are you getting the clarity? What is build and what is deployment? Okay. So build plus deployment. That is our main priority as a DevOps engineer. Project build and deployment is the main important thing for us. So earlier, companies used to follow build and deployment process manually. Because of that manual process, project delivery will be delayed because whatever is expecting by the developers, operations team is not doing that. Whatever operations team is expecting, development team is not doing that. So there will be some miscommunication between the developers and operations team when we are doing this build and deployment process manually. So now by using this DevOps culture, we are going to automate that build and deployment process. So where we are going to deploy our applications, guys? Where we are going to deploy our application? What are the servers available? Apache Tomcat is one web server for Java applications. JBoss is one web server. For .NET applications, IIS server will be available, right? So depends upon the technology, our server is going to change. Deploy the project artifact into web server. Keeping the project var file in the server is called as deployment. Apache Tomcat, JBoss, IIS, these are called as servers which are used to run our application. Are you guys able to understand the roles of the operations team? Setting up the infrastructure, for that we will use Terraform. Perform the configuration management, for that we will use Ansible. Manage the source code repository, for that we will use SVN or GitHub or Bitbucket. Nowadays people are using GitHub or Bitbucket. Build the source code, take the latest source code from repository, compile that source code. Execute unit test cases of the project. Package the code as a jar or war file. Maven or Gradle we can use to automate application build process, right? Build the source code. These all the steps comes under build process. Then perform the code review and generate the code review report. SonarQube is used to perform the code review. If any issues identified in the code review, developers are responsible to fix those issues. So then store the build artifact into repository server. Whatever the artifact created by the build tool, that artifact we need to store into repository server as a jar file or war file. Deploy the artifact into web server. Keeping the project war file in the server is called as a deployment. So whatever the build and deployment we are doing manually, all this build and deployment can be automated by using Jenkins. Okay, the code is available in the GitHub, and we need to package that code. We need to build that code by using Maven, and we need to review that code by using Sonar, and we need to store the code into Nexus repository. We need to store the code into Nexus repository, and we need to deploy that code into server. We need to deploy that code into server. Okay, several tools we are using. GitHub we are using to store the code. Maven is used to build that code. Sonar is used to review the code. Nexus is used to store the artifact. Server is used to deploy that code. So here we are working with several tools. We are working with several tools to perform build and deployment of our application. Okay, guys. So whatever the tools that we are using to perform the build and deployment manually, everything can be automated by using one tool called Jenkins. Jenkins is called as a CI/CD software, which is used to automate the build and deployment process of our project. So I want to take the latest source code. I want to build my code by using Maven. I want to review my code by using Sonar. I want to store the artifact into Nexus. I want to deploy the artifact into my server for execution. Instead of we are doing all this manual process, we can use Jenkins to automate this process. Jenkins is called as build and deployment automation software. In the Jenkins, we are going to create a concept job. Jenkins job will be available. In the Jenkins, we are going to create the job. So when we execute that job, automatically Jenkins will talk to GitHub. Jenkins will take the code. Jenkins will talk to Maven. Jenkins will build the code. Jenkins will talk to Sonar. Then it will review that code. Jenkins will upload the artifact to Nexus server. Jenkins will deploy the code into server also. Everything can be automated. Within a fraction of seconds, our code can be deployed into server. If the code is modified by the developers within fraction of seconds, our code can be deployed into server. That is called CI/CD, continuous integration and continuous deployment. So when the code is modified in the repository, immediately I want to build that code. I want to review that code. I need to deploy that code into server. Within fraction of seconds, we can complete this activity. That is called quick delivery, fast delivery. Fast delivery. So whatever the tools that we have seen, all the tools, instead of we are working with the tools manually, we can configure all those tools with the Jenkins software. So Jenkins is going to automate the complete build and deployment process of the project. It is for both CI/CD, continuous integration and continuous deployment. Are you guys getting my clarity? As a operational engineer, as a operational engineer, are we going to follow? Are you going to implement build a deployment manually, or we are going to automate that build and deployment? Are we going to build? Are we going to review? Are we going to do that manual process? Or we need to automate that process? Are we going to do that process manually, or we need to automate everything? We need to automate everything. Why we need to automate everything? Because so this build deployment is only one time activity in the project, or it is regular activity in the project? Guys, this build and deployment is one time activity in the project or regular activity in the project? It is a regular activity in the project, because every day the code is going to change. Every day we need to take the latest code. Every day we need to build that code. Every day we need to review. Every day we need to deploy. So fast delivery is required. Quick deliveries, simplifying. We are simplifying the build and deployment process. This is called a culture. The process of automating this build and deployment is one culture that companies are following now. Earlier, people used to do all these operations manually. Now we are automating everything with the DevOps practices. DevOps nothing but development plus operations. So developers will write the code. They will develop the code. We are responsible to deliver that code. So how we are going to deliver that code? By using this CI/CD software, continuous integration, continuous deployment. Whenever the code is modified, immediately I need to perform the build process and deployment process. Build is different, deployment is different. These are two activities. Build means taking the code, compiling the code, unit testing the code, packaging the code. Deployment means keeping that WAR file into server. That is called deployment. So to execute our application, build plus deployment both are required. So DevOps engineers are responsible to perform the build and deployment. Instead of we are doing the build and deployment manually, we are going to use a tool called Jenkins. We are going to use a tool called Jenkins. Okay, so automate build and deployment process. Automate build and deployment process for quick deliveries. For quick deliveries. So we are going to use Jenkins. We will use to auto Jenkins CI/CD. Jenkins CI/CD pipelines we will use to automate build plus deployments. Okay, whatever the tools we are learning, first we will learn the tools manually, how to use the tools individually. Then we are going to integrate all the tools in the Jenkins. So if you integrate all the tools with the Jenkins, this is called one project. For the DevOps engineers, what is the meaning of project? Tomorrow, when you attend the interview, so many people having a doubt. Sir, I'm attending the course. How I will get the real experience? How I will attend the interviews? How I will keep the project in the resume? For the DevOps engineers, the project means explaining the pipeline process. So how you are automating the build and deployment in your project, that only you have to explain in the interview. We are going to see 3 to 4 pipelines to automate the build and deployment for different technologies. How to deploy a Java project by using pipeline, how to deploy Python project by using pipeline, how to deploy Angular application, how to deploy microservice application by using pipelines. So all those things we are going to learn as part of that course. All right, guys. So build and deployment process for quick deliveries. So these build and deployments are going to happen in the environments like developers will use one environment, testers will use one environment. Here in the company, dev environment will be available, SIT environment, UAT environment, pilot environment, and production environment like that. Multiple environments will be available to run our application. Whatever the code done by the developers, we need to deploy the code into dev environment. So developers will test it. We need to deploy to QA environment. Testers will test it. We need to deploy to UAT environment. Client will test it. We need to deploy into pilot environment for pre-production testing. Finally, we will go for prod environment. Here, whatever the Jenkins tool we are using, this Jenkins is responsible to deploy the code into dev environment, deploy the code into dev environment so that the developers will test it, deploy to QA, testers will test it, deploy to UAT, client will test it, deploy to pilot, deploy to production. So the application which we are accessing in the live through internet, that is called production grade application. So any application which is accessing by the end users, that is called as a production application. That is called as a production application. Any application that we are accessing, that is called production application. Once the coding part is done by the developers, directly we are not going to deploy in the production. First, our application will be deployed into dev server. Then it will be deployed to QA server. It will be deployed to UAT server. It will be deployed to pilot server. Then it will go for production server. So like this, multiple environments will be available in the company to run our application, because whatever the code is done by the developers, directly we don't deploy the code in the production, because we need to test it, all the functionalities. We need to make sure everything is working as expected. If everything is working as expected, then only we will go for production deployment. Production deployment, nothing but final deployment, which will be accessed by our clients, which will be accessed by end users. To deploy the code into production, first we need to test the code in these environments: dev, QA, UAT, pilot, production. Who will use the dev environment? Developers. All the developers code will be integrated, will be built and deployed into dev environment by Jenkins. Once the code is deployed into dev environment, developers will check it, their code is working as expected or not. If the developer's code is working as expected, then that code will be given to QA team, testers. Testers are going to test our application. Then once the testers approved that everything is working as expected, code will be given to client for trial run. We can say that dry run, trial run. When you are going to purchase a car, you will go for test drive, right? Similarly, for the clients, before delivering the project, we will give for UAT. UAT nothing but user acceptance testing. Client is going to test the application to verify all the functionalities are working as expected or not. Once the client accepted the application, it will go to pilot. In the pilot environment, we are going to do end user testing. How end users will access our application. Is our application is user friendly or not? Is our application performance is stable or not? Like that we will test in the pilot. Once all these tests are completed, if everything is perfect, then only we will go for production. Production nothing but a final. End users will access our application from the production. Now see, so in the project, every day developers will change the code. When the code is modified by the developers, we need to deploy into dev environment, we need to deploy into QA, we need to deploy to UAT, we need to deploy to pilot, we need to deploy to production. So build and deployment activities we need to perform multiple times in the project. It is a regular activity in the project. So that's why it is not recommended to go for manual build and deployment. We need to automate the build and deployment to save our time. To automate that build and deployment, we are going to use Jenkins. So what is the advantage of going for Jenkins? What is the advantage of going for Jenkins? Can you guys tell me? Can you guys tell me what are the advantages of going for Jenkins? Come on, guys. To automate the build process. So are we going to build and deploy the code into one server, or we'll deploy that into multiple servers? As a DevOps engineer, are we going to build and deploy the code into one server, or we need to do that into multiple servers? Multiple servers like dev, QA, UAT, pilot, production. Who will use a dev server? Why we are deploying the code to dev server? Why we need to deploy the code to dev server? For a developers testing. For developers testing, developers are writing the code. All the developers code should be integrated and all the developers code should be tested at one place. Every developer will write the code in their computer, they will test it, it will work. But when all the developers code is integrated, how it is working? That developers has to test it. For that, we need to prepare one environment for the developers and we need to deploy the code into that dev environment. Then developers will test it. Once the developers testing is completed, we need to give the code for the testers for testing. Software testing team will be available in the project, QA team. For the QA team, we will use one server. We will deploy the code in the QA server. We'll deploy the code in the QA server. They will test it. Okay. Now, what is UAT? Who will use the UAT? What is UAT? User acceptance testing. We will give the project for trial run for the client. That is called UAT, user acceptance testing. Then pilot. What is pilot? Pilot means pre-production. Pilot means pre-production. Before deploying the project into production, we will simulate that environment in the pilot and we will test all the behaviors, infrastructure and performance, real data, Everything we will use to test our application in the pilot. Once it is success, then finally we will deploy in the production. Production means live environment. End users will access the production application. So when the developer write that code, directly we are not going to deploy to production. It should pass several phases. Dev, QA, UAT, pilot, production. So deployment, regular deployments will be available for our project. Dev environment, QA environment, UAT, pilot, production. As we have multiple environments, as we need to deploy the code into multiple environments on daily basis, manual process will take lot of time. So that's where we are going to use this DevOps practices to automate. So the process of this automating the build and deployment is called one culture that is introduced in the market, which is called as the DevOps. Earlier, people used to follow this process manually. Now we are automating this process. This is called a culture. Culture, nothing but we have some culture, right? Indian culture, foreign culture, the activities that people are going to follow, set of practices, that is called as a culture. Foreign culture, Indian culture, Chinese culture, different zone regions are having different cultures. So similarly, here we are going to follow a DevOps culture. DevOps culture, nothing but automating everything to execute our application. Automating the build and deployment process is called as DevOps culture. Why we need to automate? In the company, multiple environments will be available to run our application. Once the developers are completed the coding, directly we should not give that code to the client. We need to deploy that code into several servers and we need to test it. If everything is working, then finally we will deploy that code into production. Production means live environment. Automating the build and deployment process for quick deliveries. Jenkins CI/CD pipelines we will use to automate build and deployments. Automate build and deployment process for quick deliveries. Automate build and deployment process for several environments. Several environments like we will have dev environment, we will have the QA environment, we will have UAT environment, we will have pilot environment, we will have production environment. In the interview, they will ask you how many environments available for your application. So these are common environments in every project. Dev environment, QA environment, UAT environment, pilot environment, and production environment. Production is the final environment. The application which is deployed in the production, end users can access. So to deploy the code into production, first it has to pass in all these environments. Then only it will go to the production. So deploying the code into multiple environments on daily basis is time taking process if you do it manually. So that's why we are going to automate that. UAT, already I told. Nidadavol Sivakrishna. UAT means user acceptance testing. I already explained that. QA means quality assurance. UAT means user acceptance testing. Clients will test our application. So what are the roles of the DevOps team? Setting up infrastructure, set up infrastructure and environments, dev environment, QA environment, and all that stuff. Configuration management using Ansible, source code repository management, GitHub and Bitbucket. Okay, build the source code and build and package the source code. Maven or Gradle, we will use it. Perform the code review and generate the review report, SonarQube. Store the artifact to repository server, Nexus or JFrog. Deploy the artifact into web server like Apache Tomcat or JBoss. Automate the build and deployment process for several environments. Right, Dev, QA, UAT, pilot, production. To automate this build and deployment process, we are using Jenkins CI/CD pipelines. So Jenkins is available and in the market, Bamboo is available in the market, udeploy is available. Like that, there are several tools available. Jenkins, Bamboos, udeploy. These tools are used to automate build and deployment process. Jenkins is one of the most famous software. It is free software. Automate the build and deployment process for several environments: Dev, QA, UAT, pilot, and production. Pilot means pre-production, sir. Before going for production, it will deploy to pilot, pre-production. With live data, application will be tested in the pilot environment. Before deploying the code to the production, it will go to pilot. Pilot nothing but pre-production. Pre-production. Next one. As a DevOps engineer, we are responsible to Dockerize the application, containerize the application, execute the application in the containers. Execute the application in containers. Okay, so containerization. We are responsible to perform containerization. Containerization nothing but executing our application inside a container. Why we need to go for the container? Easily we can execute our application in any platform if you go for containerization. So understanding what is a container now may be little difficult, guys. So we are going to spend enough time to understand with containers. Docker is used to containerize the application. Docker is used to containerize the application. Containerization nothing but, so if you want to run your application in the multiple machines, so in this machine, I need to install Java, and I need to install database, and I need to install Maven. All these things can be taken care by Docker. So here, Docker we are going to use to containerize our application. That means whatever the application is available, I want to execute that application in the multiple environments. So to execute my application in the multiple environments, I need to install the required softwares. So if you go for Docker, you no need to do that. Docker will take care of the required softwares to run our application. That is called containerization. By using Docker containers, we can easily execute. We can easily run our application in any machine, whether this machine is a Windows machine or Linux machine, which version of Java is available, which version of database is available. Okay, we no need to worry about that stuff when you go for a Docker. To run one application, some set of softwares are required. Instead of we are installing all the softwares in all the machines, if you use a Docker to run the application, Docker will take care of everything. Docker will create a container for the application and it will run our application in the container. Docker containers we can execute in any platform without bothering about what operating system is available, what softwares are available in that computer. Okay, guys. Are you clear? What is the Docker? Docker is used to containerize the application. Execute the application in the containers, containerization. Easily we can run our application in any machine by using Docker without bothering about underlying infrastructure. Using Docker, we can easily execute our application in any platform without bothering about underlying infrastructure. So what softwares are available in your machine, which operating system is available in your machine, which version of Java is available, which version of MySQL database is available, which server is available, we don't need to bother about that. Whatever the configurations are required for the project, whatever the softwares that are required for the project, Docker will take care of that. Docker is used to containerize the application. Execute the application in the containers. Execute application in container. Okay, that is called containerization. Which is software we are having to containerize the application? Docker we are using to containerize the application. Now, we need to manage the Docker containers, orchestrate the Docker containers, orchestrate Docker containers. So that's where Kubernetes comes into picture. Kubernetes is called as K8s. So in order to run our application in the multiple machines, we are going to use containerization concept. Docker is used to containerize the application. And so to create the containers, to manage the containers, we need one manager. That's where Kubernetes comes into picture. Kubernetes is called as orchestrator. Kubernetes is called as orchestration platform. Orchestrate Docker containers. So what is the meaning of container? We are going to execute one application in any platform by using Docker container. What softwares are required to run the application that we no need to install? Docker will take care of that. So we'll understand more about the Docker in the coming sessions. So Docker and Kubernetes is very important for the DevOps engineer. So we are going to spend a lot of time to understand this Dockers and Kubernetes. Okay, so without keeping the Docker and Kubernetes in the resume, you will not get the interview calls. Without keeping the Docker and Kubernetes in the resume, you are not going to get the interview calls. So orchestration, nothing but managing. Orchestration means Kubernetes is orchestration platform. It is used to manage the containers. So if you go for a team, development team will be available, operations team will be available. So there will be a manager for the team who will manage the work for the resources, right? For in our team, manager will be available. Manager will assign the task to the team members and manager will check the status of the task with the team members. Manager is going to manage the work. Similarly here, Kubernetes is going to manage the Docker containers. That is called orchestration. Orchestration means management. Orchestration means management. Kubernetes will manage Docker containers like creating, scale up, scale down, increasing the containers, decreasing the containers count, and destroying. All these things comes under management. Who is going to manage the Docker containers? Docker containers will be managed by orchestration platform like Kubernetes. So alternate for the Kubernetes is OpenShift in the market. OpenShift is the alternate for Kubernetes, but this OpenShift is developed based on the Kubernetes only. OpenShift internally will uses Kubernetes platform only. So Kubernetes is called as orchestration platform. Orchestration nothing but management. Kubernetes is going to manage the Docker container. What is a Docker container? Docker container means it is the combination of application plus required softwares to execute our application in any platform. Using Docker, we can easily execute our application in any platform without bothering about underlying infrastructure. So what is a Docker container? Application code plus application dependencies. So for my application execution, I need server. You no need to set up the server. Docker will take care of that. To execute my application, I need Java. You no need to install Java. Docker will install the Java. So like this, what are the dependencies are required for your application? Those dependencies will be taken care by Docker. So because of that Docker, we can run our application in any machine very easily. So you no need to think that whether Java is available or not, MySQL is available or not. In this machine, Java is available or not, MySQL is available or not. In this machine, Java is available or not, MySQL is available or not. You no need to check that because Docker will take care of it. So you just give the code for the Docker. Docker will prepare the platform to run your application. Docker will install all the required softwares to run your application. So by using this Docker, you can run your application in any computer or in any platform without bothering about underlying infrastructure. Sir, how to create the Docker containers? How to automate the containers creation in the Docker? To automate that containers creation, we are going to use Kubernetes or OpenShift. These are called as orchestration platforms. Docker is called as containerization platform. Kubernetes is called as orchestration platform. Docker is called as containerization platform. Kubernetes is called as orchestration platform. Clear, guys? Understood? Yeah, Brundan, you are correct. Brundan Samal, Docker is nothing but collection of softwares zipped together and deployed inside a container. Correct. Application plus dependencies will be packaged. Then it will be executed in the any machine. Application plus required softwares will be packaged as a Docker image, and the Docker image we will run to create the Docker container. Simply to say that Docker container is nothing but application code plus required softwares. Application code plus required softwares will be available inside the container. So you no need to install the required softwares in any machine because Docker container will have that. So Docker container you can execute in any machine. So how to create this container, how to increase containers count, how to decrease containers count, how to remove the containers from the machine. That's where orchestration comes into picture. Kubernetes is called as orchestration platform. Now, so as a DevOps engineer, we are responsible to automate the build and deployment process, and we are responsible to containerize the application. We are responsible to orchestrate the application, and we are responsible to monitor the infrastructure. We are responsible to monitor application infrastructure, application and infrastructure, monitor infrastructure and application. Monitor infrastructure and application. Okay, so to do that, there are some tools: Grafana, Prometheus, Grafana, Prometheus, ELK. ELK nothing but Elasticsearch plus Logstash plus Kibana, like this. There are several monitoring tools are available to monitor the application. Some people will use Splunk to monitor the logs of the application. Some people will use ELK to monitor the logs of the application. Okay, Grafana and Prometheus to monitor our application infrastructure. ELK to monitor logs of our application. So as a DevOps engineer, we need to monitor the infrastructure and we need to monitor the application also. Dynotrace also is a monitoring tool. Datadog also monitoring tool. App Dynamics is a monitoring tool. So there are several monitoring tools available in the market. So as a DevOps engineer, we need to do that activity. That is part of our job. Negios is also comes under monitoring. Application performance monitoring can be done by using Negios. Guys, so did you get some better clarity than yesterday? Yesterday it was just introduction for what is DevOps. So understanding everything in one day is not possible. Step by step we have to understand. If I give you 1 kg of cake, can you eat that cake in the single shot? If I give you 1 kg of cake, can you eat that in the single shot? No, you need to take it piece by piece. So here also same thing. So some people are saying that, sir, we are not able to understand what is container. We are not able to understand what is orchestration. So it will take some time understanding. So whenever you born, directly you did not eat biryani, right? First milk, Cerelac, dal rice, sambar rice, then you came to biryani, right? It will take time. Step by step, you need to understand. Step by step, you need to understand. So yesterday I told you what is DevOps. DevOps nothing but development plus operations. So what the developers are going to do, what operations team is going to do. Okay, developers responsibilities, testers responsibilities, operations teams responsibilities, that we understood. Roles of the development team, roles of the testing team, roles of the operations team. So today I have elaborated some information related to operations team responsibilities. So as a DevOps engineer, we need to work with all the tools and we need to automate our project delivery process. We need to simplify. The main aim of the application, the main aim of the DevOps is to automate and simplify application delivery process. Okay, so we need to automate everything so that we can deliver the application quickly to the client. So we can quickly deliver the code to the testing team for testing. We can quickly deliver the code to the client for testing. We can quickly deliver the code to production for live access. So DevOps culture or DevOps practices will help us in simplifying simplifying and automating application build and deployment process. Application build and deployment process. So here, to simplify, to automate application build and deployment process, we are using DevOps tools. So DevOps tools we will use to automate build and deployment process. To automate the project build and deployment process. So what are the tools that we discussed? Maven Gradle, GitHub Bitbucket, SonarQube, Nexus or JFrog, Tomcat, Jenkins, Terraform, Ansible, Docker, Kubernetes, and monitoring tools. Are you clear? Are you clear with the roles of the operations team today? Yep. So quickly respond to my questions. Quickly respond to my questions now. Which tool is used to create the infrastructure in the cloud? Which tool is used to create infrastructure in the cloud? Respond to my questions. Terraform. Okay. Which tool is used to build the code? Which tool is used to build that code? Only Maven? Maven or Gradle? Where we will store the source code of the project? Where the project source code will be maintained? GitHub or Bitbucket? GitHub or Bitbucket? Where we will store the project artifacts? Where we will store the project artifacts? Nexus or JFrog? What is project artifact? What is project artifact? jar file or war file is called as project artifact. Where we will deploy our war file? Where we will deploy our war file? Inside a server. What is a server? What is a server? Server is a program to run our application. What is the deployment? What is deployment? Come on, please respond, guys. What is deployment? What is deployment? Placing our application war file in the server is called as deployment. Which software is used to perform the code review? Which software is used to perform the code review? SonarQube. Perfect. What is Bitbucket? What is Bitbucket? Code repository. Bitbucket nothing but it is code repository. Okay, fine. What is the purpose of Ansible? What is the purpose of Ansible? Configuration management. Ansible is used for configuration management. What is the purpose of Kubernetes? What is the purpose of Kubernetes? Orchestration platform. Manage the container. What is the purpose of Docker? What is the purpose of Docker? Managing the containers. Docker is used to create the containers. Kubernetes is used to manage the containers. What is Jenkins? What is Jenkins? To automate the build and deployment process of the application. To automate the build and deployment process of the application. Okay, guys. What is the build process? What is build process? Compilation, packaging, compile, take the latest code, compile the latest code, package that latest code. Okay. What is an access? What is an access? Difference between GitHub and Nexus. What is the difference between GitHub and Nexus? GitHub is used to store source code. Nexus is used to store artifacts. Okay, what are the monitoring tools we have? What are the monitoring tools we have? Grafana, Prometheus, ELK. What is the full form of ELK? What is the full form of ELK? Elasticsearch, Logstash, and Kibana. Elasticsearch, Logstash, and Kibana. What is Maven? What is Maven? Maven is build tool. Maven is build tool. Perfect. Perfect. Thank you, guys. I hope you got the clarity. What development team will do in the company, what testers will do in the company, what operations team will do in the company. So tomorrow we are going to understand the project development lifecycle and the DevOps lifecycle. Tomorrow we are going to understand the DevOps lifecycle in the project.